And we're live. All right. I'm going to go over. Are you guys on the page for the Hangouts on Air, the group instructions?
Yeah, it's loading.
So Holly, are you like at BYU right now, or are you home?
I'm at BYU. I'm in Pittsburgh.
Really?
Yep.
Oh. Are you just taking online classes, or is this your only online class?
One more, and that's just because it didn't my schedule. So I added it up.
Huh. That's cool.
All right. I had to switch around my screen so it's easy to navigate between them. All right. Do you guys want me to just start reading the what it says in the instructions, or just go ahead and start with the team discussion? Go ahead and start with team discussion.
Yeah, let's just start with discussion.
Yeah.
All right. Let's make sure each team member understands the 5 different transformations and the 5 important points used for transforming the sine and cosine function graphs.
Okay.
So A, I know that one is, what is it? It's like amplitude or something?
Yep. Amplitude.
B is something
period.
weird, I remember. What's B?
Did B?
B helps you determine the period.
Yeah.
Okay.
C.
There's a phase shift.
Is a phase shift, yeah.
Nice.
And then isn't it just vertical shift? I think.
Cool.
Yeah.
Alrighty. Discuss the 4 additional trigonometric functions. Be sure that each team member can tell the relationship between the 4 new ones and the sine and cosine functions.
Okay. So the 4 additional functions. Was that what was that again?
I'm actually wondering what it's referring to as well. I did the material, but I'm not sure what it's referring to. I'll look back. Did you just say something, Holly? I heard this weird buzzing noise, but
is it not working? That's not good.
It's working now.
It's working now.
It's pretty sure it's just talking about the code.
Holly, your microphone's not working.
Tangent cosine.
Whoa. All right. I think. Did you say it's talking about the tangent, cotangent, cosecant, secant?
I think that's what it is. Okay.
Those are
Okay,
the
cool.
4 plus sine and cosine.
Right. Okay.
All right. Cool.
So then, what else is it asking? So the relationship between the 4 new ones.
Secant 1 over sine. Secant's 1 over cosine. I'm pretty sure that's all it's asking.
Yeah, they're just the inverses.
Okay.
Yeah. I think that's all it's asking. But who knows?
Okay, right on. And isn't the relationship between the tangent and cosine and sine, is that let me think.
Sine over cosine equals
Sine over
tangent.
cosine. Yeah, because it was y over x. Yeah. Cool. All right. Review the answers to question number 6 from the prep and ensure each member has the correct answers. If any answer is incorrect, spend some time discussing the correct answer and how you found it. I went over all those, and I like how the key was provided, and I actually already kind of did that. If there was a question that I did have wrong, I just kept working on it until I figured it out the right way. Did you guys stop on any of them and you were just like, I don't know what's going on?
Which one was number 6? I don't remember
Number
what number 6
6,
was.
you're all
You can't.
I don't remember how to.
I have like a billion windows up right now, and I know it's on one of my windows. So let me find it real quick. All right, week 2. All right, I think I found it. Now it's just loading. All right, so number 6, that's where it said like find the sine of negative 4 pi over 3. Or it would say find the cosine of 11 pi over 6. And then you're supposed to...
Oh, it's just the unit circle stuff from last time. Oh, okay.
Yeah, so it's
Yeah, we're
basically the same stuff.
Yep.
Except last
Okay,
time
I'm
it
good.
didn't ask for...
Oh, it includes all the
Yeah, it
cosecants.
includes the 4 extra ones as well.
Yep, exactly.
Yeah, I'm good. Unless
Yeah.
you guys want to do them.
No, I was able to get them all.
Sorry. Yeah, no, I'm good.
All right. Now, let me try and find that again. Oh, here it is. Okay, so now we're down to the extension problems. Graph the following functions. Be sure to identify all 5 transformations. Plot at least one period. This will be done with the 5 important points. And identify the domain and range.
Okay. So I had a hard time trying to figure out how to do these. And so if you guys know how to do them, I'll just kind of go off of what you guys think.
This one definitely was more difficult.
Yes, it was.
So I don't know. What I can do actually that might be easier. Have you guys ever heard of Desmos?
Maybe.
No.
No?
It sounds
Okay, here. I can just plug in the equation and it'll show a prettier graph than what I can draw.
Uh-huh.
And so I can just go ahead and do that right now
Sure.
if you guys want.
Yeah, definitely.
Whoops. It'll just take me a second to plug it in.
Yeah.
I just barely had it and then I accidentally erased.
You're all right.
Okay, so this is the type of graph it gives. I don't know if
Focusing.
I can't see it.
Nope. Yes.
Oh,
It
yes,
doesn't.
a little bit.
Maybe I can zoom it in. No.
Yeah.
You have to turn the brightness down. There we go. Yeah.
Oh.
Oh.
So that's what the graph looks like, and what I'm assuming is the 1/2. You would. So we understand that the when we're looking for the domain and the range. Oh, sorry.
Through
Were
it.
you gonna say something?
Do you want me to just walk you through it?
Yeah, that would be great.
Yeah, if you know it, then let's do that. So first we're supposed to like identify all the 5 transitions, right?
Okay. That's the easiest way for me. So, graph it. But the easiest thing to do is look so on it.
What did you say? Your voice cut out.
Do you know what the -1 means at the end?
Yeah, that means it's going to do a vertical shift downward.
Yep.
1 unit.
Yep. So you just put a dot at 1 down.
Yep.
Can you see that?
Mm-hmm. Super
Okay.
fancy.
Then you do the amplitude, which is the 1/2. So I think it's easier to just draw dotted lines, which shows your parameters, which is way too small. That's the 1. So the 1/2 means it goes a 1/2 above it and 1/2.
Right.
And this is not working. Maybe this is semi-working.
Yeah.
It kind of looks nice.
And so for the range, it would be -1.5 to, well, bracket -1.5 to 0.5 bracket, right?
Right.
So that. Let's see. I remember. Next, you have to figure out the period. I forgot to do that. So do you know how to do the period?
That I don't know. I don't know how to do the period.
Let's see. 2.
Oh.
The 2 pi over b or before the x. So that's 2. So it's 2 pi over 2 pi. So that means between here and pi, it's going to make one complete sine graph.
Oh, okay.
Well, one sine wave. So it'll go down, up, and down, and hit back at pi. So that's what the first period means. Then you have to figure out the 5 point. I'm blanking. I don't.
What? Wait, what did he say, Ollie?
Let's see. I think if there is, if our voices are cutting out quite a bit, there is on the left. If you look to the left and you bring your mouse cursor over to the left, there's a column that pops up in the top. It's like a bluish purplish box. It's chat, and it might be a little bit of a pain to type up everything you're saying, but if in case there is something that we can't get across,
It might be easier to just write it out.
Yeah, good plan. Okay. So. I come through?
what is the halfway graph?
So what's that port?
Right there.
Yep.
Is that the vertex, or I don't know what it's called?
Not the name. Where is it at on the x-axis?
On the x-axis, it's in a
So
like in
here's 0.
quadrants or
No. So here's 0. Here's
Mhm.
pi.
So it's under, like, it's less
So
than
your middle
pi.
point always less your second. So it's your average. So 0 plus pi divided by 2, the pi halves.
Okay, that's cool.
All right.
So you're just finding the average of the 2 points.
Okay.
Okay. Makes sense.
Then so what's the midpoint between pi and half?
Oh man.
Could you say that again, Holly?
And pi halves.
Sorry, Holly, you keep cutting out. What did he say?
Average of pi and pi half. The average of pi and pi half. Would that just be, I want to say like 3 pi over 4.
Yeah.
Okay. So that's how you find all the points, is you just take the average of the two and that's your like third
Yes.
point. Okay.
That's it.
Oh, that's really easy.
Yeah. So you get pi over 4, pi over 4, and then pi.
Okay.
Okay.
Points. That's it.
Okay. So to identify the domain and range,
So the domain, it can really go either direction, infinite. So it'd be parentheses, negative infinity, comma, positive infinity, parentheses. The range would be, since it's vertically shifted down 1, and we know that the amplitude is plus and minus 1/2, that would mean the range would be anywhere from negative 1.5 to positive 0.5,
yeah. Okay.
if that sounds correct.
I think, yeah.
Okay,
All
let
right.
me.
So should we try the next one? Maybe?
Sounds good.
All right. So let's see.
I'm not sure what what a negative does.
It what it should
Negative 1 point.
Oh, it's negative 0.5. Not, yeah.
Oh, she's gone.
Oh, looks like we lost Holly. Oh, she's coming back.
All right, she's back.
Yay, it worked. I
All right.
think my internet died for a second. For a sec. Did it work when I typed that in?
Uh-oh.
Please don't freeze again. I don't want to have to deal with this.
Oh, looks like you're back.
Oh,
There
there
you
it
go.
is.
Yeah. I think I
That's
said
range.
positive 0.5, but yeah, it's negative
Yeah.
0.5 is the.
Yeah, there you go.
Yeah. That's, yeah. Cool. Okay.
Should we do the next one, or are we good?
Let's see. Let's see. We could just talk about it if you guys want. We could just
Yeah.
look at it and think about like, okay, so the positive 5 at the end means that it's going to be vertically shifted upward 5. The
Yep.
plus pi, that means it's going to be horizontally shifted to the left 1 pi. And then, however, what I was wondering is the fact that the 4 in front of cosine is negative, what effect does that have on the graph?
Does it stretch it? Because A is like a stretch or a shrink, and so would it stretch it or would it shrink the graph?
Like, yeah. Because, like, let's say in a normal equation that doesn't have cosine and all that stuff, what that usually does is, well, here, I could just plug it into my Desmos. Uh-oh. We lost her. And she's back. Hopefully.
Yeah.
Okay, I'm going to plug this in.
What happened, Holly?
Please. Don't know what's going on. Is it working now?
I hear you.
Okay. Maybe. Maybe. Okay. So, what was your question?
So, all right. On the next equation to be graphed, or function, I should say, we know what, the 5 does, we know what the pi does, we know what the 3 does, but I don't know what so we know the amplitude, but like,
Yeah.
since it's negative, the 4 is negative, what does it being negative change? How does it change the function?
So normally a cosine graph, you start by going down. I will draw one. It'll. You just switch which direction you draw it.
Okay.
Okay. All right.
So you literally start by going up instead of start by going down. Does that make sense?
Yeah.
So that's what changes,
Cool.
is which direction you go.
Okay.
Cool. That whiteboard is really handy.
Yes,
Yeah, for sure.
my favorite. Okay. Anything else about that one?
No, I think that's good.
Okay.
Okay, number 2. The transformational form for the 4 additional functions is the same as before. The difference is that the tangent and cotangent functions have a period of pi and not 2 pi like the other functions. The 4 additional functions also have asymptotes. So plot the parent function of each function using the unit circle. Y equals tangent of x, y equals cotangent of x, y equals secant of x, y equals cosecant of x. Identify the domain and range for all 6 parent functions. Identify the period for all 6 parent functions. Lovely.
Yay. Well, should we just start with the first one?
Mm-hmm. So,
The parent function of each using unit circle. So y equals
Okay.
x.
Do you want to do the first one, or should I? The tangent one.
Well, how
Do you know
about,
how to-
yeah, you could go ahead and do it, and we'll observe. I gotta put my laptop on the charger.
Okay. Right. Purple is not a good marker. Okay. Did the channel? Did it work?
what did you say?
Can you see it?
Oh, here we go.
Did it work?
Yeah.
Okay, so the periods, the 0 to pi, the asymptotes are the dotted lines, and then the tangent goes up like that.
What? That's crazy.
Yeah.
Yeah, so that's what the tangent graph looks like. So what? Let's see. Identify the domain. Oh, man. And so the range negative infinity and to do the domain. No?
We didn't. All I heard was, "Is that enough?" Everything else cut out.
Mm-hmm.
You know how to do the domain of the tangent graph?
I'm not sure
His
how to do
range.
that one with it repeating like that.
Nope.
Oh, okay. Well, the range is negative infinity to positive infinity because they all go all the way down and all the way up. But
Oh yeah. But not. I don't know how to do the domain.
Uh-uh.
I believe this is the one you have to use the union sign.
Oh. All right. Okay.
Oh, this is the one where you write it cannot be certain things. So you write your range is it can't be your asymptotes. So you write yeah, x cannot be pi over half 0. So you just write the asymptotes or what it can't be because it never touches those.
Right.
So it never touches the dotted lines. So that's
Okay.
what your domain is you just write the asymptotes with the name with the
That makes sense.
All right. Awesome. That's great.
Mm-hmm.
Okay.
Hmm.
So using the
When you guys want to do the cotangent?
cotangent. Let's see.
Would the cotangent just be the opposite of tangent? And like curving that way, then they'd curve the opposite way? Does that make sense?
We may lose her.
Oh, she's lost.
Nope, then she's back.
Dang. I hate my internet connection, but I can't move, so. Anyways.
Yeah, so that's the cotangent, right? What you just drew.
It just switches which side it starts on.
Right. Because it's just the inverse of tangent, so it
Yep.
would be the opposite.
Yeah.
Okay.
So that's it.
Awesome.
Okay. Someone want to do the next one?
Secant.
Yep.
Well, I'm not entirely sure how secant would view. Let's see. Where's my pen?
My markers are all dying. Ooh, that one works.
What the?
Oh.
Okay. I have a very poorly drawn graph.
That's all right.
Okay.
Might be.
It'll be grand.
Let's see if I can. That it's hard to see. There's not a lot of light, so it never touches. The asymptote is the. It doesn't ever touch the x-axis, right? Let me see what you're gonna do.
I didn't draw that one. I drew the next one.
Oh.
It can if it's like, you know how at the end you can have the plus or minus 5?
Oh, yeah.
If that changes, then it can touch the x-axis, but it'll never touch.
So on the parent graph, it won't.
Yeah, on the paragraph level.
Right.
Okay.
So like the parent graph, it has a domain of, I want to say, are those considered, yeah, those are considered asymptotes. It's pretty similar to the other one, except how did you do that? How did you put that? You put it can't equal, x cannot equal, hold on. Or can x equal anything on this one?
Are you talking about the domain or the range?
Domain.
Domain?
Because it's got like those,
It's the same as like the tangent and the cotangent
So
one.
it
Or it
equal
just
its
can't
asymptote.
go in and out a lot, but it can't be the asymptotes. That's it.
Right.
okay.
Okay. Then what's the range?
Is it
The range looks like it can be negative infinity up to a certain point. It's like
Yeah.
before the x-axis, and then don't you use union right there, and then you put above the x-axis and infinity.
Yeah. You just got to make sure to have the brackets by the union sign
right?
instead of the parentheses.
Okay. Awesome.
Yeah, that one makes sense.
And then what's the last one? Is it cosecant?
Yep.
Yep. So it's the exact opposite, right?
Kind of. Exact same, kind of. Does that show up? The original sine graph, and then showed the cosecant ones in different
Yep.
colors. Drop out
Yeah.
boy.
Okay.
It looks in range secant graph. Yep, that's it.
Okay.
Yep, got that.
Yay. Now I just have to do the group quiz.
Yeah.
Okay. Awesome.
And okay, number 1. Do you have it open?
Yep.
I'm still trying to get there. Sorry.
Okay.
My computer's just taking forever. Group quiz. I accidentally opened the group quiz submission. Okay, here we go.
Alright. List the transformations made to the cosine function and write an equation of the form y equals a cosine. Okay. Whose graph is a given cosine function? Also state the range. Okay.
Should we just go through?
So we basically have to look at the graph and kind of make a
Equation for it. Yeah.
Yeah, equation.
Do you want to just go through and do A, C, and D?
Okay. So A appears to be, is it 6?
So yeah, it goes from 10 up to 5 and half that above and below. So it'd be 3.
Oh yeah, it would be half of that.
okay.
it's times 3.
So 3.
3.
-3. See how it goes up instead of down at the start for a cosine graph?
Oh, okay.
So it'd be a -3 amplitude where it goes up instead of down.
Okay.
Okay.
Makes sense.
And then we know that it is C is let's see, so negative, what the, oh, that's a pi. That looked like 2 T's.
Yeah, it does look like 2 T's.
So we know that C is, let's see, it's going to be negative 3 pi over 2. Is that correct?
Mm. Huh. I think so.
Did we lose Holly?
She's frozen.
Oh, dang it. Yeah, it sounds like that's probably C, so let's see.
Okay.
A, C. I'm just pausing on B because I don't know what the heck.
Oh, yeah. So when you're trying to find C,
So-
what are you looking at?
So C, so what happens is C is the direction that it is shifted horizontally. So
Right. Oh, yeah.
that last one, what is it? D, that is vertical shift.
Oh, yeah.
So
Okay.
so you look at C, the one right there, to figure out where it is horizontally, and it's going to be the opposite type of, what am I trying to say? Like, it's going to be negative. So if you look at it, and it's on that 3 pi over 2, it's actually going to be,
Negative 3 pi over 2.
yeah.
Okay, that makes sense.
Okay. Hey, Holly, you there?
Yeah, can you hear now?
Yeah, now we can hear you. A little bit.
Sweet. Okay, what did you get for C?
For C, we were saying that we think it's negative 3 pi over 2.
No.
No?
Um,
Oh, dang it.
so you look at the y-axis, and you see how the first dot's on pi over 2?
3 pi, yeah. Oh, the first dot, yeah.
Yeah, so is how far away from the y-axis it is. So it'd be negative pi halves, because that's where the first dot lies.
Oh, that is the, what's that point called? The center point? Yeah. Okay.
I don't know that, but I do know that that's where the graph starts.
Yeah, yeah.
So that's what you look at. When you're looking for C, you look at the first dot point, right? Is that what you're saying, Holly? Maybe. That was good. That is what she's saying, though, right? You look at like the first.
Yeah, like what I was looking at when I said that is I was looking at that uppermost peak, when actually that's not the first point. The first point is going to be like it's not going to be on the outer. Oh yeah, Holly said yes, that's right.
Okay. So then it would be negative pi over 2, pi half.
Yep, negative pi over 2.
Okay.
So then the vertical shift, that is going to be that's going to be a positive 2 vertical shift.
Okay.
Can you hear me now?
Yeah, no, it's kind of cutting in and out, but a little, yeah.
Oh.
Oh man.
Okay. What'd you get for D?
Positive 2.
+2, yeah.
Yeah. Okay. Good.
On the last one, I was
Yeah.
looking at the uppermost peak when I was thinking it was the -3 pi half. I don't know why I was, but anyways,
I was wondering how you got that, but I wasn't.
I know I don't.
Okay,
Okay.
so what should our equation look like? So it's -3 cosine.
And then I don't know what
Oh, B.
the B.
B. So would B. I don't know. I have no ideas.
I don't know. I don't know how to solve for B. Honestly, what you got, Holly?
So how do I explain? Sorry, trying to figure out how to explain it. So the answer is a half. Like 1/2.
Okay.
You get that. Man, explanations
Well,
are hard.
you distribute, because in the beginning, you just have to distribute B, right? So would it be, I don't actually, no, never mind. Sorry.
Okay, that's how I can explain it. Okay, I figured out how to explain it. Okay, so remember that B tells you what the period is, right?
Right.
So you look at what's the period on our graph?
Well, I guess I don't understand. What is it?
Isn't cosine always 2 pi?
No,
No.
there's no B, it's 2 pi. So what you do,
Oh.
I figure out so ours goes from -pi.
Okay. Oh, lost you.
It's slowing down again.
We didn't get any of that, Holly.
This sucks. Oh, I hate my internet connection. Okay. So, what's the difference between the first point and the last point?
The first point and the last point?
Yeah.
I guess not. I don't want the domain. I guess you could say not.
Okay, so
value.
Okay, so your period is the first point to the last point. So ours goes from -pi/2 to 7 pi/2, right?
Okay.
That means our period is 4 pi.
Okay.
Because that's how many increments it goes in.
Okay. pi/2 to 7 pi/2. Oh.
Yeah, you do. I'm writing it down.
Okay.
Okay. So we figured out that it's 4 pi, right?
Yep.
Right.
We know that you get the period by doing 2 pi/b.
Yep.
So then you just figure it out by putting 4 in for the equation. So you get a half.
Oh, okay.
So b equals 2 pi over 4 pi, which is a half. Is that good?
Oh, yeah.
Sense.
2 pi over b, and b was 4 pi, so 2 pi over 4 pi, and then we get 1/2. Awesome.
Yeah, is that good?
Super
Yeah.
good.
Okay, I'm going to put it down. It's hurting my arms.
That's great. So we have, was that -3 cosine, and then bracket 1/2, parenthesis, x minus pi over 2, parentheses, bracket plus 2.
No.
X plus pi over 2. Because it goes to the left. So it's x2 in the parentheses. It's left.
No.
Does that make sense?
Okay. Yeah. It's just written out on the question as x minus c.
Yeah.
So
That's
I
because
mean,
normally it goes to the other direction.
okay.
So this isn't horizontally shifted to the right?
Yeah.
It
It should be that.
Okay.
Cool.
Got it. Okay. Does that make sense to everybody? Can you move on? Oh, we need to find the range. We have the range.
So what's the range?
The range will be -1. So a bracket -1 to bracket to 5, +5 bracket.
Yep. That's it.
Okay.
So Holly, could you actually explain to me the so it's actually positive pi half for the, what is that, c?
See? Yeah.
Positive. And so is the point that we're looking at the one that is at -1, well, negative pi half -1 for that? Uh-oh. Oh, okay. For some reason, I was looking at the point.
Make sure that's positive.
Okay. What the point that I thought we were looking at was the one that's at pi half 2, pi half comma 2. That middle one. I thought that's the one we were looking at.
Yeah. Yeah. Always look at the first one, the farthest left. So I
Okay.
guess.
Cool beans.
Okay. Next one.
Sine of alpha.
Cosine alpha equals 2/5, and sine alpha is 0. Okay. Wow.
What the heck?
So do you know which equation we use?
No, actually.
Is there
So you start out with that.
Oh, okay. Yeah, that makes sense.
Then do you want to just see if we can figure it out? And go back to the end, see what our answers are?
Yeah.
Okay.
Actually, that does make sense.
Okay.
Okay, I got an answer, but I don't think 99% sure that it's not right. So,
I just type them in instead of.
does anybody have an answer to that? Me either.
Well, hey,
Molly?
I understand the concept of that, like this sine square theta plus cosine square theta equals 1. That makes sense to me. However, I'm not sure how to implement, like, like the a squared plus b squared equals c squared, and we know that it's gonna equal 1. I'm not sure how to put in. We know. Let's see. Where did it say that cosine of alpha equals 2/5?
Right.
And where we're supposed to plug that in. Hey Holly, you're frozen. I'm not sure if you can hear us, but I think we're pretty lost.
Yeah, that's where I got stuck. I mean, I tried to just like plug it in, but it didn't go anywhere.
Well, did you get like 0.999 something?
Something like that, yeah.
And it just, I don't know. I don't know what happened.
Yeah, I don't know. But Holly's frozen. So.
Oh, here we go. Actually.
Okay, wait. Let me try that again.
Well, let's check this out. Maybe we're headed in the right direction. Nope, I
Finally
wasn't.
come back.
What was that?
Am I finally back?
Yeah, you are. Welcome
I just
back.
sign all the way out and get back in because it completely closed me out. That's different. Okay, what did you guys get on the equation?
Oh my goodness. I know that what I got isn't right. I got like 0.999 repeating.
Okay, what did you get?
Okay, so we were kind of confused on, so we understood like the overall equation where sine squared plus cosine squared equals 1. But then since we know what cosine is, it's 2/5. So do we just plug that in? Like
Yeah.
we were kind of confused with that.
Yeah, so what did you do to plug it in?
Do you want to see my whiteboard?
Yes. So select.
Yes.
Does it make sense even though I didn't show the steps in between?
Okay.
One moment. Oh.
I mean, I know it's right because I checked it. Because if you do sine times that number plus cosine 0.4, you'll get 1. So I know that's right.
Okay.
But
So,
you get the steps.
how did you enter that into your calculator? The cosine squared of 0.4?
So to do that, you have to do the cosine of the number first. Because you'll get an inaccurate answer if you try and put the squared in. So you do
Okay.
cosine of 0.4
Okay.
equals. And
Okay.
I probably should have said this earlier, but make sure your calculator's in radians and not degrees. Because that's what I did the first time I did this equation, and it made no sense.
Ooh.
That
And
would be
now
my
it
bad.
is. No,
Was that
no.
your problem?
Maybe.
Let's see. I don't think so. Probably not.
Okay, well, that's what
We'll
I
say
did the
it was,
first
but
time.
it sounds like I have a good excuse. Just kidding.
Pretty valid excuse. I mean, it's what I did the first time. So you have to do cosine of 0.4,
Okay.
and then you have to hit the equal sign,
Okay.
and then you have to square it. So you have to do the squared after, which is kind of
Now I'm
confusing, where it's in the middle. It doesn't make any sense, but you have to square it after.
Okay. Let me do that. And then I got it.
You got it?
Yep.
Yay! Did you get it, Tessa?
Maybe.
Or which part's confusing?
So you find the cosine of 0.4 and then you square that number. Then what do you do with that number afterwards?
Okay, so then you have to subtract it from the 1. So you have to get it on the other side.
All right.
Okay. Then you get to this point, right?
Uh-huh.
And you just want to get rid of the squared. So you just square root this.
I read it. Okay,
That's how
yeah,
you get
I got it.
0.34, 384, 389.
Right.
Sorry, can't read my handwriting.
Okay, got it.
And then if you want to make sure it's right, you just do sine of this squared plus the cosine of 0.4 squared equal, and it'll equal 1. I did it just to make sure I was right. I didn't want to. You'll know.
Cool.
Can we move on? Are you guys good?
Okay.
Yeah. So what is next?
Use the fundamental
Use
trigonometry.
the fundamental.
Sorry.
You can go ahead and say it.
Okay, use a fundamental trigonometric identity to write two functions for cosine alpha in items of sine alpha. Indicate which formulas to use for a given value of alpha. Okay.
Okay. I know 1. I don't know 2.
Okay.
You can use that same equation we used on the last problem.
Okay.
All right.
I think maybe this is not what it's asking for. Not 100% sure what this one's asking for, to be honest.
Try to identify two functions for cosine A and items of sine A.
I don't know if that's what it's asking for, but that's what I thought it was asking for. Because it's writing cosine in the form of sine.
Right.
But I'm not 100% sure.
Actually, that makes sense.
Yeah.
Let me read it again. Use a fundamental trigonometric identity to write two functions for the cosine alpha and items of sine alpha. Indicate which formula to use.
Yeah, so that's the Pythagorean theorem.
Yeah.
But I don't know what else it's asking for. I don't know another one.
Mm.
The only other idea I had tangent in there, and I feel like, I mean, it wouldn't have cosine in it, but it would have tangent in it, not just sine. Just confusing to me. So I don't know.
Yeah, I know.
Hold on. Maybe. Give me a second. I'm going to try something.
Two functions.
No, that won't work. I don't know.
Mm.
Value of A. Given A.
I don't know.
I can't, honestly, I don't understand the question very well. Like what does it mean in items of sine alpha?
Yeah, that's what's confusing to me. I don't know what it means by items.
Right. In items of sine A.
I don't know. It doesn't make sense to me. But that first formula, I think it makes sense. Maybe if that's what it's asking for.
Indicate which formula to use. Two functions for cosine A items of alpha. Honestly, I just don't even know what to even speculate because it's I just don't understand what it's asking for.
I don't either. Such a weird question.
It's just weird. Awful.
What would you guys like to do? Would you guys like to? We could. I could shoot him an email or something and ask him if he could just reword that question and we could get back together tomorrow just for probably like all of a couple minutes to do that one question. Whatever you guys want to do.
Yeah, sure. I mean, that's fine.
Yeah.
What do you think, Holly?
That's probably fine. I'll probably remember it the second we get off the freaking chat, though.
Like, figure out what's going on?
Yeah. With my luck, that's probably what would happen.
Yeah.
Sure.
Might as well just wait.
Let's go ahead and shoot him an email right now.
Maybe he'll email you back quick. That'd be nice.
That actually would be really nice. Here, I'll just... His last name is Jordan. Jordan. What was it?
Jordan. It's
Scott Jordan.
I don't know if he'll email us back tonight, but I have to go. So, I mean, if we remember it, then I guess we can just meet up again tomorrow. But
Okay. Just
Yeah.
barely sent it off. But yeah, likely he won't. He's not just sitting on his email just waiting for, students to email at 9:22 p.m.
yeah.
I'll keep you guys updated with what he says though, and if any of us do kind of understand what it's asking for, we could we all have each other's numbers. We can just throw it into the group message. What I'm going to do is I'm going to look through the study material and try and figure out what it is asking for, and I'll let you guys know if I do find anything.
Okay. Yeah, I'll look too because I don't know what it's asking for. It's kind of bothering me.
Well, right on. Man.
Got a lot done.
Alrighty.
Yeah.
Well, I guess we'll just talk tomorrow, and more than likely the group meeting tomorrow. We probably won't even need to, I don't even know how to add on to this video, but we can just meet without broadcasting it. It'll probably take all of a couple minutes, and we'll figure it out, and then be good.
Yeah.
Yeah. Sure won't be that big of a deal. Just not to have it broadcasted.
Yep. Alrighty, well, you guys have... Well, actually, I'll just stop broadcasting.